When we talk about timing in animation, we tend to be referring to the amount of frames attributed to a given movement. The more frames, the slower the movement. The less frames, the faster. On a purely physical level, correct timing makes objects appear to obey the laws of physics. For example, an object's weight determines how it reacts to forces. Like in our bouncing ball animation, the speed relays a feeling of the approximate weight and air resistance of the object in relation to gravity. For example, a balloon requires a lot less force to move it than, say, a bowling ball. Additionally, timing allows us to convey character. For instance, a sad character could be slow and lumbering, and an excited character be fast and snappy. Although, you should remember, character isn't just for characters. We can apply these ideas to inanimate objects as well, giving life to cubes and spheres and text and, well, anything you can imagine. So let's open up our blend file and take a look at what we've got. We've got 3 cubes moving in a linear fashion, linear interpolation across left to right across our screen. Now all 3 are exactly the same, they're all identical, except our top one's got something called a motion path applied to it. Now, what's a motion path? Motion paths are a visual representation of an object's path through 3D space. So, they're comprised of 3 different elements, these little dots which represent frames, these big orange numbered dots which represent keyframes, and the lines that join these dots together. So essentially a dot is plotted marking an object's position at each frame of an animation, as you can see here. In fact, I'm just going to go to wireframe, and you can see at any given frame, the actual origin of our object is sat exactly on top of one of these white frame markers. These dots are then joined up in sequence to create a single path that represents the object's journey through space. So we can actually see where an object will be at any given time. So this is a really useful and powerful tool. I should also just make you aware that it doesn't update automatically. So once you've made changes to an animation, so for instance, I'm going to insert a keyframe for our Z location, and then I'm going to move and add another keyframe further down, and then I'll add, let's just copy this one, and yeah, great. So now you can see our cube is moving, but our motion path isn't updating. All we do to change that is we just click Update Motion Paths. Lovely jubbly. So now you can see it's actually showing us the arc of our cube. So that's what motion paths do. How do we add them to an object? Well, we can select the next cube down, and we come over to the properties panel, and we go to the object data properties, and under motion paths you'll find a bunch of buttons, but the only one which really interests us is the calculate button. So let's hit that and then just click OK. So yeah, as you can see, now it's created, easy as pie, a lovely motion path for us. We can just repeat that for the next cube down as well. And we're pretty much good. If you do need to delete a motion path at any time, feel free to just come over, select your object, and just click the X button. In fact, we'll do that now. As you can see, deletes it. Nice and easy. So anyway, 3 cubes, 3 motion paths. We'll hit Alt-A to play, and let's start experimenting. I'm going to select our second cube down, and what we're going to do is we're actually going to change the interpolation on it. Before we do this, it's very important, in our graph editor, we've got to turn on our selection filter. And what that's going to do, it's going to mean that we're only seeing and only manipulating the animation data of our selected object. Otherwise, we would have actually been adjusting all 3 of our cubes, and this would have all got very confusing very, very fast. So, yeah, selection filter on, and then with the mouse over the graph editor, hit A. You might have to hit it twice, and that will allow you to select both our keyframes. And then I'm going to hit T, and we're going to choose Interpolation Bezier. And as you can see, it's still got a linear animation going on because our keyframes and their handles are actually all still aligned, which is unfortunately pretty useless to us. So what we're going to do is hit V and change the keyframe handle type to auto clamped, and that will bring them into this nice S-curve gentle easing. So great, I'm just going to open this panel up because I know I'm going to need it in a little while. And yeah, obviously our motion path hasn't updated yet, so let's do that. We'll just click Update Paths, and what you'll see is in stark contrast to our first cube's motion path, which has these nice uniform, evenly spaced frames, now we've got some quite densely distributed frames here. and they start to get wider around the center, and correspondingly our animation starts slow, gets faster, and ends slow again. So the density of these dots, the density of these frames, is actually dictating the speed of our motion. Our keyframe animation hasn't changed, so the keyframes are still, the information in those keyframes is still identical, but the interpolation between the two has changed drastically. So let's take a look at a more extreme and maybe opposite example with our third cube. I'm just going to select it, and then again I'm going to go into the graph editor, hit A twice to deselect, and then select all. And again, I'm going to hit T, I'm going to choose Bezier, then we're going to hit V, and we're going to change the keyframe handle type to auto clamp just to get that nice S in there. And if I select one of our keyframes and then just pull this down here, you'll see it's auto clamped, but as we discussed earlier, if I grab this handle and move it manually, it's going to become aligned, which is great. That's fine. It's a manual type that we want, and I'm just going to drag the handle till it's nearly vertical, or till it is vertical, I suppose, and then the same for our other keyframe. And as you can see, we get this quite severe curve, and I'm just going to update the motion path so you can see what that's actually done. Starting and ending really widely dispersed frames. I mean, there's huge jumps in the actual animation now, so it moves really fast and then very, very slow as the frames are distributed more densely. So that's how we can visually represent timing and spacing in 3D space in Blender's 3D viewport. That will allow us to be more informed and therefore create more capable, more beautiful animations within Blender.